Let's take a look at an application that will use an Osmose connected to a Haken Audio control voltage converter so we can convert MPE keystrokes into CV output that will control an XAOC Odessa module. This is an additive oscillator that lets you manipulate 2650 harmonic partials in various ways. You can look up the module itself. That's not the main focus of this discussion. But the Osmose will control main parameters of the module, the pitch, basic, volume, output, and one of the various parameters, tension, on the module. But the main thing about this video is we're going to use a Slim Continuum connected to an Evaton Technologies micro CVC, uCVC, to allow the Continuum to basically become an XYZ controller that will output CV according to where you have your finger on the Continuum surface, and that CV will control other parameters of this module. X, for example, will control the harmonic factor of the module, Y of the Slim Continuum will control the partials, and Z will control tilt. So we basically will have 6 degrees of freedom here, X, Y, and Z control from the Osmose, and X, Y, and Z control from the Slim Continuum, both of which are set as polyphony 1 devices because we're playing this module as a monophonic oscillator. Now the setup we have here is that the Osmose is connected to the CVC. When you do that, you connect the DIN out of the Osmose to the DIN in, which is really I squared C in of the CVC. You set your Osmose to 5.5 CVC configuration in the MIDI I/O global section. And then we're going to output the X, the 1 volt per octave pitch of channel 1 of the CVC, because we're only going to be outputting a monophonic voice, so only channel 1 will be output. X is going to connect to the 1 volt per octave input of the module. Z, pressure, is going to be sent into a mult so we can split that out to control both the even and the odd partial output of the module. The green lines here feed the even and the odd partials into the quad VCA, only using 2 channels of it, and the Z output is going to control the volume basically of the output of those partials, and the audio output of that is sent to an effects processor and then to the mixer. We're not really concerned with that for this video. Y from the Osmose is going to be sent and control the tension input, and on the Slim Continuum side we connect the Slim Continuum to the uCVC with a special cable that comes with the uCVC that connects to the TRS I squared C output of the Slim Continuum, and then the uCVC will map to fingerboard, again set polyphony 1. Since this is a single channel output device, that works well for this application. I'll send X in to control the harmonic factor input of the module, Y will control the partials, and Z controls tilt. So that's the basic setup. Now on the Osmose end, we're going to program the CVC. We'll use simple formulas, A, B, C, and D. We're actually not going to use a gate output from the CVC or the uCVC. We don't need it in this case because the VCA is going to map the pressure that we induce on both the Osmose and Slim Continuum. On the Osmose end, formula B is set to octave mode, basically sending out a 1 volt per octave CV output for X. Y is set shelved here from a value of 0 to 2. Y is also set to use the first macro controller, which we set as tension, so we can control that with macro controller 1. And Z is just set 0 to 10 volts output that, again, we're feeding into the VCA to control the output volume of the Odessa module. The Slim Continuum sets X as a linear value of 0 to 5 volts because I'm not using X on the Slim Continuum as a 1 volt per octave pitch input. I'm just using it as a linear min to max 0 to 5 volt output that I control the Odessa module with. Y I'm setting as a shelved value going 0 to 4 volts using a squared transfer function, and D is set as it is on the Osmose, pressure going 0 to 10 volts. You can play with these and you can set microcontrollers on them also if you want to vary their ranges. So let's see how this works and how the Slim Continuum can become basically a controller and not an instrument per se.
XAOC